Welcome to Energy Central Power Perspectives Podcast. This is the show where we bring in thought leaders and innovators across the utility industry and grill them about the future of the industry and learn about how they're making that utility of tomorrow a reality today. My name is Jason Price of West Monroe, and I'm coming to you from New York City. Joining me, as always, is Energy Central's community manager and podcast producer, Matt Chester. Matt, we're diving into the future of microgrids today with one of the key players working in that space to solve some of the energy sector's biggest hurdles. Are you ready to hear about the microgrid opportunities that might be coming your way soon?
I sure am. It's a topic that's gotten a lot of great buzz, and that's what we're here to do, is to learn some more.
Indeed, so let's set the stage. The modern U.S. grid is seeing numerous weak spots being highlighted pretty consistently these days. Subpar resilience and reliability, a clean energy transition that's got to move faster than it's been, increasingly common severe weather events undermining grid reliability, stricter environmental regulations constantly coming our way, and more. And in an effort to overcome these challenges, the cost to the customer to get their energy really can't afford to rise. So, how do we tackle all these various challenges? Luckily, we can make real and affordable progress toward overcoming these hurdles with one shared solution, and that's microgrids. Microgrids are poised to reduce service interruptions, to allow for easy integration of distributed clean energy sources, and to provide redundancy, resilience, and a hardened grid. And unlike some other solutions being tossed around, microgrids aren't something we have to wait around for. Rather, they're being used by utilities, municipalities, and large energy consumers across the country today. To share some of the ways microgrids are forging a new path to the utility of tomorrow, we welcome to the podcast Bruce Schadler. Bruce is the Director of Project Management at SourceOne, an energy consulting company for Veolia North America. A New York State licensed engineer with over 20 years of experience, Bruce is one of the foremost leaders on microgrid design and implementation. The projects across the Empire State with his fingerprints on them are impressively vast and varied. From implemented microgrid projects at William Floyd School District to NYU, Intrepid Air and Space Museum to Hudson Yards, Kings Plaza Mall, and more. He's also performed feasibility studies for microgrids at New York Presbyterian Hospital, New York Power Authority, New York Public Library, Grand Central Terminal, and various SUNY campuses. Clearly, his projects truly stretch across many major New York institutions. That experience makes him an expert on not just how to design microgrid projects, but also why different stakeholders should take a long, hard look at implementing microgrid projects of their own. And the market is agreeing with them, with the growth of such projects only accelerating. And before we bring Bruce into the podcast booth, let's give a quick thanks to Veolia North America for making today's episode possible. As many of you may know, Veolia North America is a leading environmental solutions company serving customers in water, waste, and in energy in the US and Canada. We are pleased to be partnering with them to show how the energy market is evolving and highlight the latest innovations and trends that are best poised to meet the challenging needs of energy consumers, providers, and producers. With that said, let's pull Bruce into the conversation. Bruce Schadler, welcome to today's episode of Energy Central's Power Perspectives podcast.
Thank you, Jason and Matt, for having me today. I look forward to sharing my perspective and experiences around microgrids today.
Bruce, let's start with defining what is a microgrid. Who are the buyers, and has this changed over time?
I think there's a lot of interpretations out there around what a microgrid is. Size, does it have to be a certain size? Does it have to be part of the utility grid? I think to me, the definition of a microgrid is some type of distributed generation that's connected to the utility, either operating in parallel or independently, but is able at some point to operate independently around the grid where you have a defined border. So having said if the grid goes down, then this generation can supply the load for whatever said facility. I think it's important to understand too that I don't feel microgrids are new. I think they've been around for several years. I mean, if you look back to small municipalities and even large industry campuses. They've had large generation in place for over 30 years for different reasons, for distribution reasons where the utility couldn't get out to them, or their load is so big that they couldn't upsize feeders to get to them. So I think based on that, they've been around. They've been classified more as combined heat and power rather than microgrids. But as they connect to the utility grid, they truly become microgrids. I think the buyers you see nowadays have kind of migrated from the small munis and the industrial campuses, and you're seeing more hospitals, malls, smaller size generation, 5 to 10 megawatt. Reasons for this and why it's changing over time. I think deregulation in the markets some years back had a lot to do with it. I think the utilities are becoming more flexible with their standards and policies. There's definitely a rise in need for reliability and independence due to what seems to be a lot of natural disasters, if you will, coming into play. There's also been a large increase in technology and controls, which has been lowering the capital cost to install a microgrid and making it more available for a wider range of users. And then you always have the hedge against increasing energy costs. So I think with all of that, you're starting to see large 60 megawatt plants start to go to a megawatt, 2 megawatt in hospitals, malls, and start to enjoy the benefits of a microgrid.
Okay, well, since our audience is from the utilities, describe the relationship and interaction of your work developing microgrids with the utilities.
Interactions with utilities, I would say, is kind of a love-hate relationship. The first step in any microgrid development is to meet with the utility to understand their policies, rate structures, interconnection requirements, what goes along with fault mitigation, and sometimes franchise agreements, because in some districts or utilities, they allow you to cross one public street, so you could potentially tap an owner or prospective client on the other side of the road. Some, it's only adjacent property. So you got to really kind of understand their policy towards it in the franchise agreements as you're developing these microgrids. But, usually we meet with the utilities during a feasibility stage to, review the project requirements and the customer's goals and to make sure we have a path forward. I think it's also important to understand that you need to have the utilities to have buy into what you're trying to do with the microgrid in order to have a good, successful project. Early on in my career, William Floyd School District being one of my first projects that I worked on, we had a difficult time out there working with the utility. We used to call the utilities, cogen killers, right? Or nowadays microgrid killers, because their requirements would be very strict, which leads to extra equipment needed, increased capital costs, which, unless you had stellar financials, really destroyed it. And I think, they would come out and say that they supported CHP and such, but I think in the end, they were just looking to increase their revenue. I think nowadays there's definitely been a change in policy and understanding towards interconnections and microgrids and their advantages.
Okay, but are utilities getting into the microgrid development business? Or are you seeing utilities buying finished projects? Are they competitors to you when they develop, or how do you position that?
I think that's a great question. And I think we've worked with several utilities, one in Southeast Canada, in developing microgrids that they were interested in purchasing. Reason for it, there's a lot of large scale end consumers in industrial steel mills, carbon black mills that really large loads, 10 megawatt, 15 megawatt. They don't have the distribution, as you can imagine, where they can deliver the power that's needed. So they understand that if they can come out and develop a microgrid for them, they'll have this customer. And I think with the advent of all these indoor grow farms that you see popping up, there's really a large demand for power. The utility understands that it would be astronomical to develop the infrastructure to get the power to them, but rather a microgrid a local microgrid as a solution. We've also done some work with the Puerto Rico Power Authority. Took some meetings with them, again, around distribution issues after Maria came through Puerto Rico. As I'm sure everyone knows, there's some parts of the island didn't have power for, up to 9 months. They were looking at how we look at the specifications, the requirements, how we interconnect. I think in a nutshell, what they were looking for was there a way to have their large end users, whether they're some type of manufacturing or stuff, but have their own generation where if they had a natural disaster, they could segregate parts of the grid and have these distributed generation backfeed out into the grid and pick up the local towns and villages, if you will, around the manufacturing plants. So to answer your question, yeah, I do see the utility getting involved in developing microgrids, not as a competitor, but as a partner.
I know you've also mentioned that microgrids can be integral to recovery during natural disasters. Can you explain for us the role they can play in those situations?
Sure. I think a great example I always kind of throw out there when we're talking on this topic is NYU Square down in Lower Manhattan. During Superstorm Sandy, most of Lower Manhattan was shut down by the utility, Con Ed. One, for protection, and two, because most of it was underwater at that point. There's a great picture out there of Manhattan taken 30,000 feet up or so, whatever. And you see this little square of light in Lower Manhattan. And that was NYU Square because they had their own microgrid cogen at that point, and they were able to keep the lights on and keep the facilities running. So I think that's a great example of how beneficial a microgrid can be, where during normal times you can share power with the utility, but in the event of a natural disaster where the utility has to shut down, you can potentially run your plant and keep operations going. Natural disasters, I mean, they definitely spur other microgrids. The Air and Space Museum at the Intrepid, they put in a microgrid as a result of Superstorm Sandy, as did Hudson Yards kind of took inspiration from that when considering putting in a microgrid and building their development out. So I think you can definitely see how natural disasters definitely influence microgrids and how they can play a role in those situations.
Terrific. All right, let's talk concrete examples. You've implemented some state-of-the-art microgrid technology at the Hudson Yards development complex. So walk us through that project. What was the initial problem to be solved? How did you scope out the solution? And what were the ultimate outcomes?
Yeah, just to give you a little background on the Hudson Yards development. It's located on the west side of Midtown Manhattan. And, it kind of acts like a small city in itself with multiple buildings of mixed use, which is, rental, residential, office, etc. The design it's a 13 megawatt microgrid, and it's situated on the roof of the mall, the retail mall there. I think after Superstorm Sandy hit New York City, I think there was a huge movement towards resiliency. I think that was a big motivating factor for Related and the Hudson Yards development to move forward with it. I think it was a positive selling point for future tenants. And I think it made economic sense if we could pick up the whole campus. And that's kind of where the challenge came in, was how do we pick up the entire campus, putting in distribution and connecting without driving up the cost too much to make this uneconomical. And the strategy we kind of came up with was interconnecting to utility, but in utility feeders, right? So this was kind of unusual and the first of its kind in New York City, where we're actually going to put breakers into the utility distribution. I mean, usually when you do connections, it's on the house side of the utility meter. This was on the utility side of the meter. So we really had to work with Con Ed and their policy to come up with a specification that we could all agree upon to make this happen.
So what are the financial implications of all this lost load to Con Ed? Who's the local provider? Who's winning and losing in this equation?
I view it as a win-win. I think that the customer receives the reliability that they're looking for and the economic savings. I think that the utility benefits from having that load freed up from the grid. And it also demonstrates that the utility is open to change and new solutions when looking to install microgrids. So I think that goes a long way with public favor. In other situations, the microgrid can provide power to the grid, as I was discussing earlier, and that will also reduce operating costs to the owner.
Bruce, I've toured the Hudson Yards microgrid, and it's an impressive structure. And we know that the underpinning value of the microgrid at Hudson Yards was its resiliency, as you pointed out. How do you value resiliency?
I think it's tough to value resiliency unless it's measurable in dollars, of course. For something like Hudson Yards, the resiliency would come through in leases, right, and rentals and tenants, getting valuable tenants to sign onto leases. I think if you take a look away from Hudson Yards and you look at other industries that we work with, sometimes they measure resiliency in the fact of if their process is down, what does that cost them, right? You can look at, we've done work with Johnson & Johnson, and if they lose power for more than 2 minutes, they have to go through a whole cleaning process, and being down for a day was worth $4 million to them. So I think you can put a price tag on resiliency if it can be measured.
Perfect. When it comes to microgrid technologies, do the projects you implement have any, say, special sauce? What does your platform offer that's really elevating these solutions to the next level?
I would say as far as technologies go, we evaluate everything based on what our customers' goals are. We're impartial to technologies, and we don't rep or push any one type of technology. And I do think customers appreciate that. I'd say the special sauce that we have is our model and performa. It's the tool in which we use to evaluate all our opportunities. And it has the ability to evaluate different technologies at the same time.
So tell me, once you stand up a microgrid, do you also get into the rate design?
Yes, I think depending on the situation, Veolia has a group that advises on rates and commodity. We advise on rate structure to the people that take power off of the microgrid. Sometimes it's a simple PPA, a power purchase agreement, where it's just based on a discount against the utility rate. Other times it gets a little bit more complicated, where we consider capacity, commodity, and transfer and distribution charges. I know at Hudson Yards they had several different rates down there, just based on how many clients they had, and they had a tier structure to sign up for backup different levels. So depending on what tier you signed up for, you had a different rate. So we did advise on that at Hudson Yards, and we also do a lot of negotiating with the utilities for rates on the utility side, just not on the power purchase side. Since these are very unique projects, when we approach the utility, sometimes they have needs and they're willing to negotiate with us. Sometimes this can be, being able to export on a particular rate that you're not normally, or we definitely negotiated reducing standby capacity charges, which is what happens when you have, distributed generation connected to the grid. And even at Hudson Yards, I believe we did the buyback rate, so it was neutral for us to push power back out to the grid, so the grid could capitalize on getting power injected into the grid. And at the same time, at Hudson Yards, we could run the engines at full efficiency, 100% efficiency, giving us a better performa. So that's kind of how we work with the rates around a microgrid or cogen.
Understood. Bruce, share with us what the past year has been like. What's it been like regarding the adoption of microgrids, and just generally speaking, what you've seen in the marketplace this past year, given COVID in the economy?
To be honest, I haven't really seen any slowdown in interest on microgrids, given the recent pandemic and economic slowdown. I think we're starting to see more studies than ever looking at microgrids. I think there's a financial savings as a driver for these. And I think with the corporate initiatives that are coming out to go green and reduce carbon footprint, as well as, the government policy now on greener energy, I think all that has been shifting momentum into microgrids. Just based on that, I think microgrids are starting to come into their own.
Bruce, tell us how this microgrid offering fits within Veolia's Hubgrade platform for digital innovations and solutions.
I think microgrids are are one of the technical solutions that Veolia offers under a Hubgrade service. The service is kind of an umbrella type concept for digital innovation. It offers, greater sustainability, energy efficiency through, real-time energy management. Hubgrade it's a way for us to basically help customers improve their performance, whether, it's a building, microgrid. Ways I've used it and we're trying to work it into with microgrids is a make-buy type analysis where we use the RTEM, the real-time energy management, and we look at several factors, for the operating efficiency of the plant, cost of production at that moment, what's the real power cost from the utility, and we can basically decide time of day if it makes sense to run the microgrid or if it makes sense to import power from the utility. So we're using Hubgrade in that way with microgrids for the customer to improve their overall performance and their financials.
Gotcha. Now let's look forward. What's the future of microgrids, and how are you and your team working to make the future reality?
The future of microgrids is interesting because I think you have to look at the microgrid with the macro grid, if you will. What I see in the future is microgrids interacting with the macro grid to provide power in spot networks where needed. And what it'll do, it'll help offset some of the capital costs to upgrade aging infrastructure and distribution throughout the utilities grid. So you have these microgrids that will produce locally to the communities that's needed. I think a good example of this is a project we just did out in Brooklyn, Kings Plaza Mall, where we connected to the grid and they had excess capacity, as I was describing earlier on. And what they do during demand days is they export 6 megawatts of excess spinning reserve they have to the local community. And it's able to keep the lights on there, where in the past they've had to have, brownouts and such. So I see the future of microgrids kind of acting that way. Maybe it's a little bit more integrated with the utility, but I can see that definitely being the future.
Very nice. So Bruce, this has been a terrific conversation, and we really appreciate you letting us pick your brain on everything that's microgrids. You'll have to check back into the Energy Central community platform to continue to update us on the state of the industry and the fascinating projects you continue to put into the world. Thank you so much for joining us today.
Thanks for having me. It's a pleasure talking.
You can always reach Bruce through the Energy Central platform, where he welcomes your questions and comments. And on behalf of the entire Energy Central team, thanks to everyone listening today. Once again, I'm Jason Price. The most relevant conversations of the utility industry today are happening in the Energy Central community. So we look forward to you joining us and sharing your insight at energycentral.com. And we'll see you next time on the Energy Central Power Perspectives podcast.